Hi, welcome to our grade 8 week 1 and our objectives to be able to factor completely the different types of polynomials by number 1, common monomial factoring, number 2, difference of two squares, number 3, sum and difference of two cubes, and number 4, perfect square trinomials. And without further ado, let's proceed to our common monomial factoring. Okay, now, so here are some steps for us to remember how to apply common monomial factoring. Number 1, find the greatest common factor of the numerical coefficients. So as you could remember when you were in elementary and grade 7, finding the GCF, if you could remember that, finding the greatest common factor is one of the topic that was really drilled into your head. How to find for the greatest common factor? It's because on your later years you would still apply the greatest common factor. Now, find the greatest common factor of the numerical coefficients. As you can see, we would focus on the numerical coefficients having their greatest common factor. Now, let's have an example to make it easier for us to understand. Let's have an example. Let's say 6x plus say 18xy, say minus, let's say 20, let's say 20, let's say 20x to the 4th. For example, this is our first example on the common monomial factoring. Okay, examples. That's because we would have many examples later on. Let's focus on to this first. Let's read. Find the greatest common factor of the numerical coefficients. If you could remember, the numerical coefficients are those numbers that are on each and every term that we have. For example, on our first term, our numerical coefficient is 6. On our second term, our numerical coefficient is number 18. It's 18. On the third term, our numerical coefficient is 20. Now, let's focus on the numerical coefficients. So what are the numerical coefficients? We have 6, we have 18, and we have 20. And the question now is, what is their greatest common factor? So what is the greatest common factor? If you're asked about the greatest common factor, it is just the same as what number can you divide to all of them? What's the greatest number that you could divide, that you could use to divide in all of them? That's how we would answer what is the greatest common factor. And what number can we divide on all of these numerical coefficients? We have, let's say, can we divide 3? Yes, 3. How about on 18? Yes. How about on 20? No, we cannot use 3. I guess in this one, the GCF is only 2. Okay? So the GCF here is 2. Let's have 2. Now, that is our, for the first one, 2 is the greatest common factor of 18, 6, and 20. Okay, now let's go to the second step. Let's read the second step. Find the variable with the least exponent that appears in each term of the polynomial. Let's have this. Variable with the least exponent. Least. Okay? Having the least exponent that appears in each term. Now, what are the variables that we have? We have x, we have x and y, and we have x. Now, as you can see, x and y are the variables that we are using, right? X and y. And now, let's answer this question first. What variable appears in each term, in all of the terms? So we have x here, we have xy, we have x, and then therefore y would not be included. Okay, y would not be included. It's because y does not appear in each term. Okay, so on our factor, y is not included. It's because y did not appear in the first term, as well as y did not appear on the last term. And let's have x. How about x? So x appeared on the first term, x as well as appeared on the second term, and then on to the third term. So therefore, our factor now would be x. So now let's have that x, and then let's focus to this statement, least exponent. So our factor would on the variable, our variable, the factor that we would use is the variable that would appear in each of every term, and as well as the least exponent. So that's this one. What is our exponent? On the second degree. How about this one? It's on the first degree. And how about this one? It's on the fourth degree. So you have second degree, first degree, fourth degree. Then what would be our least exponent? Then therefore, we could say our least exponent is on the first degree, right? So therefore, our factors would be 2x. That would be 2x. Why not 2x squared? Why not 2x squared? It's because it's not 2x squared. It is because it is not the least exponent. Why not x to the fourth? Because it is not the least exponent. And why x? Because it is the least exponent. Okay? Now, next step. The product of the greatest common factor in A and B is the GCF of the polynomial. Now, if we are talking about polynomial, the GCF of the polynomial would be the product of the numerical coefficient and the variable. Okay? So the GCF of the numerical coefficient and the variable that appears in each of every term with the least exponent, that would be the GCF of the polynomial. So we would multiply. We have 2 earlier, and now we have the x. 2 times x, that would be 2x. And now, our greatest common factor here would be 2x. Now, let us continue to our fourth step. To completely factor the given polynomial, divide the polynomial by its GCF. The resulting quotient is the other factor. Now, what was the keyword? We would divide. Since our GCF now, okay, our GCF is 2x, then we would divide, okay, the polynomial, our main polynomial, we have 6x squared plus 18xy minus 20x to the fourth. We would divide it by its GCF. And our GCF is 2x. Now, let us divide it by 2x, okay? So, now, let's divide. We have okay, 6x squared divided by 2x. Okay, we have 6x squared divided by 2x. That would be 6 divide 2. That would be 3. X squared divide x. That would be x. Copy the sign. 18 divided by 2. 18 divided by 2. That would be 9. Xy divided by x. That would be y. Copy the sign, minus. 20 divided by 2, that would be 10, and then x to the fourth divided by x, that would be x cubed. Okay, and then the resulting quotient is the other factor, and that's all. This is our other factor. And then we completely applied common monomial factoring. Okay, let's have another example. Let's have 25x cubed y to the second degree minus, let's say, 15x squared y to the fifth, say, plus, say, 100. I'll say 100 x, y, x, let's say x, there's only x, then y to the fourth. Okay, now let's have the first process. Okay, Let's have the first process. What's the first step? We would find the greatest common factor of the numerical coefficient. So what is the greatest common factor of the numerical? By the way, let's put an equal sign. I'm acquainted with putting equal sign. So let's have that one. Okay. Okay, let's continue. So an equal sign. Okay, now, what's the greatest common factor of our numerical coefficient? So our numerical coefficients here, on the first term we have 25, on the second term we have 15, and on the third term we have 100. And what's the greatest common factor? When you are asked what's the greatest common factor, what greatest number you can divide to all of them. Now if you have a problem, okay, if you have a problem finding the GCF, you may apply the prime factorization. Okay, apply the prime factorization if you have a problem on finding the GCF. And by the way, prime factorization is very important. It's because you not only the GCF, when using prime factorization, you can find for the GCF, you can find for the LCD of bigger and many numbers. Okay, now though the process is quite very long, but you would arrive at a definite answer. Okay, now let's continue. What's the GCF? The GCF is 5, or rather 5, okay, because on 3 terms, 25, 15, and 100, the 3 of them could only be divided by 5. The greatest that could be divided to them is 5, and the next is 1. Which is greater, 5 or 1? Then it's 5. Therefore, the GCF is 5. Now, let's go to the second step. Find the variable with the least exponent that appears in each term of the polynomial. So, let's focus on the variable. We have x, we have y, we have x, we have y, we have x, we have y. Okay, so on all of the terms, it appears that we have the variable x and y. How about the least exponent? So on x here, we have cube. On x here, we have square. On x here, we have on the first degree. So what is the least exponent? Of course, it's the first degree. On y, on the first term, our y is on the second degree. On the second term, our y is on the fifth degree. And on the third term, our y is on the fourth degree. So the least exponent, 2, 5, and 4, the least is this square, or in the second degree. And then afterwards, we will divide, okay? Divide the polynomial by its GCF. When it is a polynomial, the GCF would be the product of the numerical coefficient, the GCF of the numerical coefficient, and the GCF of the variable. Let's multiply those, and that would be the GCF of the polynomial, okay? So let's divide them one by one. 25 divide 5. That would be 5, right? X cubed divide x. Now here's the thing. If you would divide variables, you may simply subtract their exponent, okay? So 3 has a higher exponent. Here, x here is having an exponent of 1. 3 minus 1, that's x squared, okay? Now how about this one? Y squared divide y squared. Y squared divide y squared. That would be 2 minus 2, that would be 0. So therefore, we would have no longer the variable y. Then let's have minus 15 divide 5. That would be 3. X squared divide x. 2 minus 1, that would be x. Y to the 5th divide y squared. That would be y cubed. And plus 100 divide 5. 100 divide 5, that is 20. Then we have x divide x, that's equal to 1. X divide x, that's equal to 1. So we are no longer writing it because 20 times 1 is still 20. Y to the 4th divide y squared, that will be y squared. And this is our other factor. And the factored form of our second example using the common monomial factoring is 5xy squared times the quantity of 5x squared minus 3x cubed plus 20y squared. This is our factored form. This one, applying the common monomial factoring. And that's it. That's common monomial factoring. That's applying common monomial factoring. If you wanted more examples of this, you may comment down below for more examples. Okay, comment down below on our YouTube so that I will give you more examples. Okay, and let's continue to our next one. We have the difference of two squares. As stated, difference of two squares, this way of factoring is only applicable to the difference of two squares. As you can see, it's really right there, word for word, difference, meaning the middle sign is a subtraction sign, difference, and two squares. There would be only two terms, and those two terms are squares. Okay, so difference of two squares, this is only applicable to a polynomial who has only two terms, and those two terms are perfect squares, and of course the sign on the middle of those two terms is a subtraction sign. Okay, now so here are some steps for us to be reminded on how to do factoring a polynomial using the difference of two squares. First one, find the square root of each terms. Find the square root of each terms. And then the next one, write the product of the sum and difference of the two squares. As easy as that. Okay? Now, so it's very easy for us to remember when to use factoring difference of two squares. It's because we would factor out two squares and having a middle sign of subtraction. Now, examples. Let's have few examples. I guess we would have maybe 2 or 3. First, again, we would only apply this on two terms. Okay, let's have the first one. Let's say x squared minus y squared. As easy as that. This is our first example. Now, again, difference of two squares is only applicable if there are two terms. 1, 2. And the sign on the middle is subtraction. It's because we are having the difference. Difference, it's subtraction. Okay? Now, let's continue. Okay. Now, find the square root of each term. So, this is the first term. This is the second term. And let's find the square root. Okay? The root. Okay. Now, what's the square root of x squared? Square root of x squared, that would be simply x, right? The square root of x squared, let us write this here first. The square root of x squared, you would just simply, okay, what would you do? You would just simply cancel out the exponent and the radical sign, right? The square root and the exponent. So therefore, the square root of x squared would be, that is 2. On the first step, find the square root of each term. So that would be x. And what's the square root of y squared? Square root of y squared, that is simply y. Okay, so we now have the square root of each terms. We have x, we have y, and then the next step, write the product. The product of the sum and difference of the square root. So the product, this would become the quantity of, we have the sum, so let's have plus for the sum, and we have the product, the quantity of, say, x, and then the difference, and y. And this is now our factored form, factoring the polynomial difference of two squares. So our factored form, the quantity of x plus y times the quantity of x minus y. Let's have another example. Quite difficult. Let's have another example. Let's say this one. Let's say x squared minus, let's say, 121. Now, again, let me remind you, difference of two squares is only applicable on polynomials having two terms. Those terms must be a perfect square, and of course, the sign on the middle must be a subtraction sign. If this is plus, we cannot apply difference of two squares, okay? Now, let's find the square root of each term. What is the square root of x squared? That's x. What's the square root of 121? That is 11. 11 times 11, 121. So our answer, our factored form would be x. Okay, let's have the sum first, 11. And then the quantity of x and the difference, and then 11. Okay, so write the product. So that's why we had the two quantities, the product. By the way, if they are enclosed in a parenthesis, it means that it is a product. Okay, we would apply multiplication in this one. Write the product of the sum. So here's the sum, x plus 11, and the difference, x minus 11 of the two square roots, of the square roots rather. So the square root of x squared, that's x. The square root of 121, that's 11. So the quantity of our factored form would be the quantity of x plus 11 times the quantity of x minus 11. Let's have another example. Number 3. Now let's have another example. Let's say we would have 81 x x to the 4th y square minus, let's say we would have 36 y to the 6. For example, this one. Take note, 81x to the 4th y square is still a perfect square, and 36y to the 6 is another perfect square. So therefore, we could still apply factoring difference of two squares. Okay, now let's continue. So let's answer the first questions. What is the square root of 81? What's the square root of 81? That is 9. How about x to the 4th? What's square root of x to the 4th? And that is x squared. And how about y squared? What's the square root of y squared? That would be y. And then, okay, let's have the sum. So this would be the quantity of 9x squared y plus, what's the square root of 36? Square root of 36, that's 6. 6 times 6 equals 36. And what's the square root of y to the 6? That's y cubed. Okay, so let's have the sum. And then the difference would be 9x squared y minus 6y cubed. Okay, that is now our factored form. So our factored form, the factored form of 81x to the 4th y squared minus 36y to the 6 is the quantity of 9x squared y plus 6y cubed times the quantity of 9x squared y minus 6y cubed. And now let's continue to our third one, sum and difference of two cubes. And there are two kinds here. We have the sum of two cubes and the difference of two cubes. We need to bear in mind with that one. It's because the sum of two cubes has a different form compared to the difference of two cubes. But they are just similar, but they have a simple difference between the two. That's why we must bear in mind if it is a sum of two cubes or a difference of two cubes. Now let's proceed to the first one. Let's have the sum of two cubes, and here are the things, are the steps that we need to do in order for us to factor a polynomial. To factor a polynomial that is a sum of two cubes. Okay, the first one. So let's have an example. Our first example for the sum of two cubes, let's have x cubed plus y cubed. Okay, let's just follow the steps so that we could easily find out, or we could easily factor this type of polynomial, the sum of two cubes. Okay, so for the first step, let's follow the first step. Find the cube root of the first and last terms. So the first term, our first term here is x cubed. Our last term is y cubed. So we would find for the root rather than the cube root. Okay, so what's the cube root of x cubed? So the cube root of x cubed would be x. So we need to remember our how to find for the root, the square root and the cube root. In this case, we would have the cube root. This is a topic of grade 7 math. So what's the cube root of x cubed? So that would be x. And the cube root of the last term. What's our last term? That's y cubed. So what's the cube root of y cubed? That would be y. Okay? Now, write. Now let's go to the next step. Write the sum of the cube roots as the first factor. So we would write, so these are the cube roots, and then we would have it as the sum. Write the sum. So this would be plus, okay, because write the sum. So the sum of the cube roots would be x plus y, and we would write it as our first factor. So therefore it would become the quantity of x plus y. This is now the sum of the cube root. What is the cube root of x cubed? That's x. What is the cube root of y cubed? That's y. And let's write the sum of the cube roots as the first factor. So now we have the quantity of x plus y as our first factor. Now let's go to the third step. For the second factor, get the trinomial factor by. Now meaning, as clearly as it is stated, the second factor would become or would be a trinomial. Our first factor is a binomial, 2 terms, and our second factor would be a trinomial, meaning there are 3 terms. Okay, so let's follow the 3 steps. Then again, A, squaring the first term of the first factor. So let's square the first term. Square the first term of the first factor. Now, this is the first factor, x plus y, and this is the first term, this is the second term, and we would get the square, okay, by squaring the first term. So the first term would be squared. What's the square of x? That would be x squared. And then let's follow letter B. Subtracting the product of the first and the second term of the first factor. So now, right now, on the second factor, on the trinomial factor, we would refer to our first factor. Okay, the steps A, B, and C are all referred to our first factor. So the first step, square the first term of the first factor. So x raised to the second power, that's x squared. Then subtracting the product of the first and the second term of the first factor. So subtracting the product of the first and second term of the first factor. So now we would have the product of x and y. So x times y, that's xy, right? The product of x and y is xy. So the subtracting now, this is subtracting, that's why minus the product of the first term and the second term of the first factor. X times y is equal to xy, and then we did the subtracting. Then the last one is squaring the last term of the first factor. What's the last term? The last term is y. So y raised to the second power, y raised to the second power, that is y squared. And this is now our factored form for the sum of 2 cubes. So let's have another example. Let's have 8m cubed plus let us say 64. Okay, 8m cubed plus 64. So this is our next example. So let us follow the steps for the sum on factoring this sum of 2 cubes. Okay, the first step, find the cube root of the first and last term. So what's the cube root of 8? So let's do it separately. Cube root of 8, that is 2. 2 times 2 times 2 that is 8. So that would be 2. What's the cube root of m? So m times m times m, that's m cube. So definitely the cube root of m cube, I mean, is equal to m. And then let's have the 64. What is the cube root of 64? So what is the number that we multiplied 3 times to itself that would be equal to 64? And that is 4. So 4 times 4, that is 16. Times 4, that's 64. So therefore, the cube root of 64 is 4. Now, this is now the cube root of the first term and the cube root of the last term. Then, the next step, write the sum. So we would write the sum of the cube roots as the first factor. So therefore, our first factor is the quantity of 2m plus 4. It's because on our next consecutive steps, we would base on our first factor. Okay? So now let's continue. Squaring the first term of the first factor. So we would square the first term of the first factor. Our first factor is 2m. So we would square or raise it to the second power. So 2 squared, that would be 4. M squared raised, or m raised to the second power is m squared. And then subtracting the product of the first and second term of the first factor. So we would multiply our first term and second term of our first factor, and then we would subtract it to our first term. Now, 2m times 4. 2 times 4, that's 8. And that would be 2m times 4, that would be 8m. Okay, so squaring the first term, the first factor, here it is. Subtracting the product of the first and second term of the first factor. So subtracting the product of the first term and the second term of the first factor. And then finally, we would do the squaring of the last term of the first factor. So we would square the last term. So we would square the last term of the first factor. So what's the square of 4? So that would be 16. 4 times 4, that would be 16. And finally, this is now our factored form of the sum of two cubes. Now, let us proceed to the difference of two cubes. Now, here are the steps for us to factor the difference of two cubes. Okay, so let's have an example. Let's go directly to the example. It's because difference of two cubes is somewhat similar to sum of two cubes, but we just need to bear in mind few things. Okay, now our first example. Okay, so let's have an example, and our first example would be with x, not big letter, x cubed minus y cubed. So this is our first example, x squared minus y cubed. As you could see, sum of two cubes, it would be, of course, the sign here would be plus. In this case, we have the difference of two cubes. That's why our sign here is a subtraction sign, a minus. So now let's apply the steps. First step, find the cube root of the first and last term. It's the same. It's quite the same with our sum of two cubes. So first step is for us to find the find the cube root. Okay, this one. Okay, for us to find the cube root. So our cube root, the cube root of the first term, which is x cubed, is x, and the cube root of the second term, which is y cubed, that would be also y. And then for the next step, write the difference. Okay, this time we would write it as the difference. Our first factor would be a difference of the cube roots. Okay, so now it's difference. Okay, our first factor is difference of cube roots. The same with the sum of two cubes. We would our next factor would be a trinomial, and for the trinomial we would all base it to our first factor. Okay, the next step is squaring the first term of the first factor. Our first term is x, so x raised to the second power, that's x squared. And then now we have adding the product. Right now we would add the product of the first term and the second term, x times y, that's xy. And then lastly, squaring the last term of the first factor, y raised to the second power, that is y square. Okay, and that's it. This is now our example for the difference of two cubes. Okay, so how did they differ? The sum of two cubes from the difference of two cubes? We could say on the sum of two cubes we would write the sum. Here we would write the difference, and then in this case we would do the subtracting the product of. In this case we would have the adding the product of, so that would be addition, here would be subtraction. Okay, let's have another example. Example number 2. Let's have p cube minus, let us say, 125. Okay, p cube minus 125. So now this is a difference of two cubes. There are two cubes, and then the sign on the middle is a subtraction sign, difference of two cubes. Now let's follow the steps. Find the cube root of the first and last term. What's the cube root of p cube? That is p, and the cube root of 125. So what are the numbers that we multiplied 3 times to itself equal to 125? And that is 5. 5 times 5, 25 times 5, 125. Okay, now the next step, write the difference of the cube roots as the first factor. So our first factor would be the quantity of p minus 5. P minus 5. Okay, the difference. Now for the second factor, get the trinomial factor by squaring the first term of the first factor. The first term is p raised to the second power, that would be p square. Then adding, the next step, adding the product, so that would be addition sign of the first term and the second term. So p times 5, that's 5p, so plus 5p. And then squaring the last term of the first factor, so 5 raised to the second power, or 5 squared, that's 25. And okay, and that's it. So the factored form of the difference of two cubes, p cube minus 125, is equal to the quantity of p minus 5 times the quantity of p squared plus 5p plus 25. Okay, and right now let us continue to our perfect square trinomials. And now let us go directly to our examples. So our first example would be x squared plus 4x plus 4. This is a perfect square trinomial. It's because the first term is a perfect square, and the last term is a perfect square, and the second term is equal to the twice of the root of the last term. Okay, so now let's continue. How to factor perfect square trinomials? It's very easy. The first step is get the root of the first term. So what's the square root of the first term? X squared, the square root of x squared, that's x. Okay, x. Then since the sign here, as you can see, it's plus sign, then we would follow it. The sign of the middle term is plus, so let's have the plus sign here. Then let's get the root of the last term. What's the square root of 4? And that is 2. And that's it. And let's do it twice. So we have x plus 2. Okay. And now this is the factored form. And our factored form of our perfect square trinomial is the quantity of x plus 2 times the quantity of x plus 2. We would just simply get the root of the first term. So square root of x squared, that's x. Then copy the sign of the second term, that's positive, so plus. And the square root of the last term, and that is the square root of 4, and that is 2. And just do it twice. So the quantity of x plus 2 times the quantity of x plus 2. Okay, so let's have another example. Okay, let's have it here. Okay, how about if the sign of the middle term would be a subtraction sign? Let's say our second example, x squared minus 4x plus 4. Okay, what if here we have addition plus 4x, here we have subtraction minus 4x? So we would still follow the same steps. Extract the root of the first term and extract the root of the last term. So what is the square root of x squared? That would be x. Then since it is minus, let's follow it, minus, subtraction sign. And then we have the square root of 4, that is 2. And then let's do it twice, the quantity of x minus 2. Okay, and now our factored form of the perfect square trinomial x squared minus 4x plus 4 is equal to the quantity of x minus 2 times the quantity of x minus 2. Let's have another example. Okay, so our next example would be y square, same, plus let's say 10y rather, plus 25. Now, okay, this is another example of a perfect square trinomial. It's because the first term is a perfect square, the last term is a perfect square, and the middle term is equal to the twice, or rather than it is equal to what's the square root of 25? That's 5 times 2, it's 10. In order for us to check the middle term, we would get the root of the third term and multiply it by 2. Okay, so the twice of the root of the last term. So for us to check the middle term, so that we could confirm that it is a perfect square trinomial, because sometimes trinomials are not always, or rather let's say trinomials are not always perfect square trinomials. They could be general trinomials. Okay, in this case, this is a perfect square trinomial. It's because the middle term is equal to the twice the root of the last term. Okay, now let's factor it out. What is the square root of the first term? Square root of y squared, that is y. Then let's follow the middle sign. This is plus, so that would be plus. Okay, and then what's the square root of 25? That would be 5. And let's do it. Okay, then again, y plus 5. So our factored form for our third example, y squared plus 10y plus 25 is equal to the quantity of y plus 5 times the quantity of y plus 5. Okay, so for our last example, number 4, we have 4x squared plus 24x plus 36. Okay, now our last example is quite different from our first 3 examples. Okay, so let us continue. As you could remember earlier, I said to you regarding with the common monomial factoring, there are cases that before we could apply the other kinds of factoring, we must first apply common monomial factoring. Could you remember that one? And our last example is that one, that case. Okay, so as you can see, we have numerical coefficients 4, 24, and 36. We have variables x squared and x. And as you can see, the variable is not present on the third term. Therefore, we do not have a GCF of the variable. So we would only focus on the numerical coefficient. And for 4, 24, and 36, what is the GCF? And the GCF would be 4. right? So now let's use it. Let's divide now. Let's divide now. So 4x squared divided by 4, that would be x squared, plus 24 divided by 4, that would be 6, plus 36 divided 6, rather than 24 divided by 4, that would be 6x. It's because 24x divided by 4, and 36 divided by 4, that would be 9. Now, as you can see, we now have 4 times the quantity of x squared plus 6x plus 9. So as you can see, x squared plus 6x plus 9 is now a perfect square trinomial. Then that would be the time we could apply factoring the perfect square trinomials. Okay? So what is the square root of the first term? We have square root of x squared. That would be x. And what is the square root of the last term, which is 9? Square root of 9, that would be 3. And the middle sign is plus. So let's copy plus 3. And then, okay, let's do it 2 times. And this is now our factored form. So the factored form of 4x squared plus 24x plus 36 is equal to the quantity, is equal to 4 times the quantity of x plus 3 times the quantity of x plus 3. Okay, so I guess that would be all for grade 8 week 1. So if you have further questions, you may comment down below, and or you can message me, okay, on YouTube or on Facebook. Okay, so thank you and God bless.